An F-15E Strike Eagle pilot is forced to eject over deep, hostile territory in Iran. He makes it to the ground safely, but his situation is immediately precarious. He is alive, but stranded. The immediate problem for the extraction team is that standard survival gear is effectively useless. Flipping on a GPS beacon or transmitting a distress call over radio frequencies will instantly broadcast his coordinates to enemy forces. The military faces an impossible vacuum. The rescue squad needs a continuous, unjammable tracking signal to lock onto his position, but that signal has to come from the pilot naturally, without relying on any external hardware. The solution lies in human biology. With every single contraction, the human heart generates its own microscopic magnetic field. To find the pilot, they just have to listen for it. But detecting that faint biological whisper from up to 64 kilometers away requires a massive leap in sensor capabilities. It requires a technology known as ghost murmur. The first barrier to actually executing this track is the physics. The magnetic pulse of a human heart is astronomically weak, easily drowned out by the Earth's ambient magnetic background. To measure that microscopic field, scientists use superconductivity. Cooling materials to near absolute zero removes electrical resistance. Placing an insulator between superconductors forces electrons to jump the gap, creating a Josephson junction. Combining two creates a hypersensitive squid, perfectly capable of registering a human heartbeat. Squids work flawlessly in a controlled laboratory, but dragging giant, fragile vats of liquid helium through a desert for a stealth military extraction is completely unworkable. The military needs a quantum sensor that can survive reality. It has to operate at room temperature, in rugged, unforgiving environments. To bypass the extreme temperature requirement, engineers turn to synthetic diamonds, specifically grown with highly intentional nitrogen and vacancy defects. Inside the diamond, microscopic flaws act as traps. A single caught electron becomes highly reactive to subtle local magnetic changes. Through the Zeeman effect, these trapped electrons become room temperature sensors. As the pilot's heartbeat washes over them, they physically react by shifting their light emission. By replacing cryogenic vats with flawed diamonds, the detection of quantum magnetic fields was unshackled from the laboratory. It became a deployable tool. But deploying the sensor reveals a final macro-level hurdle. Pushing that diamond's detection range out to 64 kilometers forces the system to absorb the chaotic electromagnetic noise of the entire planet. The diamond sensor's microscopic precision is immediately overwhelmed by massive, continuous interference from radio towers, underground power lines, and even the Earth's natural magnetic shifts. To solve this, advanced artificial intelligence is fed the raw data. The software ingests that massive, continuous wall of environmental static and begins scanning for microanomalies. The AI has a highly specific filtration task. By methodically scrubbing away the Earth's background noise, it isolates the exact rhythmic fingerprint of the stranded pilot's heartbeat hidden underneath the static. Locking onto a biological target from 64 kilometers away requires a perfect hardware-software synthesis. The quantum diamond hears the data, and the AI understands it. Using this filtered quantum signal, the extraction team zeroes in on the pilot's precise location. They complete the rescue without a single intercepted transmission. That isolated military operation highlights a broader technological reality. It proves that human beings can be tracked passively over vast distances, based entirely on their internal biology. Traditional surveillance relies on external links. Facial recognition requires line of sight. Mobile phones and GPS require hardware. All of these can be spoofed, abandoned, or simply turned off. Ghost Murmur removes the choice. As quantum sensors and AI filtering scale up, a person's heartbeat becomes an involuntary, unmaskable biometric identifier. The very organ required to keep you alive is rapidly becoming a permanent broadcast of your identity and exact location, available to anyone with the technology to listen.